Hello everyone, I'm Li Shipei from 5 Roma. Today, this video is going to show you how I complete my additional mathematics project. So basically, we are given three topics to choose, and I have selected the third chapter's topic, that is integration. So this question, basically it's about predicting the price of gold by determining the amount of gold needed to make the product. Okay, uh, this question is considered is consisted of three parts and further investigation and reflection. So the first part, we are going to look what are the factors that influence gold price. So firstly, uh, the factor that influence gold price is supply and demand. So this basically means that gold is needed in some fields like making jewelry or industrial fields. So for industrial fields, there are like products like medical devices, precision electronics that requires gold to make. So the second factor is inflation. So basically, during inflation, the money currency decreases drastically. So more investor, they invest in gold because gold price increases, so they can gain higher returns. So the third factor is interest rates. So interest rates is inversely has an inverse relationship with gold price. So if interest rates increases, the gold price decreases. Uh, in contrast, if interest rate decreases, the gold price increases because when more investors buy gold, uh, gold has a higher demand, so the gold price increases. The last factor is central bank reserves. So basically, there are banks in every countries. They store gold so that they can control the gold market. The so they prevent flooding sales of gold that will cause the dampening of gold price, that is the decrease in gold price. So for part 2, I'm going to solve the first question. So this question basically is about finding the maximum volume of the mold. The mold is used to make gold pieces. Okay, so first I analyze the question and I get the information that the perimeter of the cross section, okay, is 60 cm. Uh, so I can co- so I can come up with this equation, that is 2y plus 2x. 2y plus 2x. 2x is the diameter of the semicircle. So basically it's first the rectangle plus pi x. Pi x is uh, the length of arc. Okay, so it's equals to 60. So I can get y in terms of x. Okay, the next step is I find the equation of the area of the cross section. Okay, so basically it's 2xy plus 1 over 2 pi x squared. Basically it's just the area of the rectangle plus the area of the semicircle. So by doing this, I'll substitute the y into the 2, equation 1 into equation 2. So I can eliminate the y, and I can get a in terms of x. So after this, I will do the differentiation dA dx. So for maximum volume, for maximum values lah, differentiation dx equals to 0 shows that we can find the maximum value of the equation. So by doing that, I can get that when I can use the second derivative to double check that uh, my 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 assumption that a is maximum when x equals to this value. So by knowing that when x equals to this value, a is maximum, I can direct substitute this x value into the area equation. uh, the area equation is here. Okay, I substitute the x value into it and I can get the maximum cross-sectional area is 252.04 cm squared. So this is the cross-sectional area. So in order to find the volume, I will times 1, that is the same answer lah. But the difference is it is the maximum volume of the mode. So this is my final answer. So the third part is I will find the volume of the gold, okay, of the this is the golden ring, and I need to calculate the cost of the golden ring. So uh, it is given the function, the equation in the graph, okay. So firstly I will find the corresponding x values because I need to integrate this area so in order to find the generated volume of the ring. So in order to get this ring shape, because if I just integrate the area under the graph, that is this area, it is just the cross-sectional area. But if I rotate this area about the x-axis uh, 360 degrees, I can get the ring shape. So to do this, I need to find the corresponding two x values first. So I substitute y equals to 1 into the equation. So I can get x equals to 1 over 5 or negative 1 over 5. So next, I will do the volume generated that represents the volume of the ring. So I just substitute into the formula, that is integrate BA pi y squared. So this is, and then for x as for the ring, if I just rotate this area, I can just get a perfect circle. So it is not yet a ring. So I need to deduct the area, the generated volume between this 0 to 1, that is also a circle. So I use the big circle minus the small circle and I can get a ring shape. Okay, so basically it's uh, that is my solution. Okay, by doing this I'm doing the integration method, and then I can get the final answer. The volume of the ring equals to 0.362 cm cube. So after I get this, in the question it mentioned that the density formula. So we already get the volume of the ring, and then the density of the gold, I find this through the web. It is 19.3 gram per cm cube. So I substitute the value of volume and the density into the equation. I can get the mass of gold needed. So after I know the mass of gold needed, I also check through the website. Okay, I check through the website of the gold price, and then I get the value is 1 gram of gold equals to 252.28 ringgit. So I multiply the mass with the price per gram, and then I get the cost of the golden ring is 1762.58 ringgit. So that is my final answer. So for the further investigation is basically just similar 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 like the last question, the previous question. So this is the bracelet. So it did it didn't give me any graph, so it asked me to the question asked me to get a desired bracelet thickness. So I just do two quadratic equations uh, to get like the cross-sectional area of the bracelet, just like the question above. So it's the similar solution that but this one a bit different is I use the because I need to find the cost of the bracelet based on the size of my own wrist. So I measured that my wrist size, the perimeter is 18 cm. So this one is much more easier. So I just directly use after I calculate the cross-sectional area, I will multiply it with the wrist size so I can get the volume of the bracelet easily. So this is basically my solution. So same as the previous question, I use the density formula and then I find the mass and then I multiply with it with the price per gram of gold and I get my cost of gold bracelet 7,303.51 ringgit. So after that, the question asks me to uh, calculate the cost of the bracelet if other materials are used such as silver, iron and copper. So I just make a table of comparison between the prices for different metals. Oh, okay, just like just now the density, the price per gram, all I find through the website, and then I will get different costs of bracelets here. So basically copper and iron will require a very small cost because both these metals are found abundance in on the earth, but they are less attractive than silver and gold. So the question asks me to choose the best material to make the bracelet. I will probably choose silver metal because gold is too expensive, and then uh, actually silver is also attractive. Uh, just gold is gold in color and silver is gray in color. Both silver and gold are shiny, and then they are more attractive than copper and iron. Uh, so I will choose silver to make my bracelet because it costs a more affordable price compared with gold. That is 58.06 ringgit. So the last section is the reflection section. So through the project, I can learn that the integration can be used to determine the amount of material required to make an irregular shaped product and predict the cost needed. Just like just now, the bracelet, the rings, they are irregular shaped objects. So I can use the knowledge of integration to determine the volume of the objects. Okay, so these are the other applications of integration in daily life. So basically, integration can also use to find the weight of curve-shaped objects, in biology field, it can use to determine the bacterial growth rate, and then in field like physics, it can use to determine the center of gravity of an object, and also the velocity and trajectory of an object, that is mainly the pathway traveled by an object, patterns. Okay, so in chemistry field, it can be used, integration can be used to determine the rate of chemical reaction. Okay, lastly, integration can also use to predict the behavior of the 3D graphics uh, on a display, so we can know what kind of animation we can get before we do the graphics. So okay, basically that's all for my project. That is all how I complete my project. So these are the websites I use for reference. Okay, okay, thank you.